Vaccine stops deadly sandfly spread scourge in animal test. Vertical line biomedicine. Vertical line science news. Subscribe archives register log in. Atom cosmos. Body brain. Earth. Environment. Genes cells. Humans. Life. Matter energy. Molecules. Science Society. Other. ESN Kids. 09 Vertical line 21 Vertical line 13 Issue. Contents Collision Course. Scientists struggle to make windows safer for birds. The tune wreckers. Lousy singers make the pitch for scientific relevance. Subscribe. Give a gift. Renew. RSS feeds. Email alerts. Digital edition. Podcast. Past issues. Read articles, including science news stories written for students, on the SNK website. Contents Alien cart leap onto the scene. Invasive fish break people's bones and threaten native species. Video games. When Granddad wins. With some practice, people over 60 bested untrained 20-year-olds meet the new meat. Scientists made a hamburger without harming animals, but it cost as much as a house. Home/news. Vaccine stops deadly sandfly spread scourge in animal test. DNA immunization protects hamsters and mice from leishmania parasite. By Nathan Seppa. Web edition, September 11, 2013. A+A, text size. DNA immunization protects hamsters and mice from leishmania parasite. By Nathan Seppa. Web edition, September 11, 2013. Enlarge. Prepping for invasion. Preventing the leishmania donovani parasite shown, untreated from hijacking heme from its hosts may be key to creating a vaccine to combat the scourge. Credit, L.R. Haynes et al/P. Bellows Neglected Tropical Diseases 2009. The lethal parasite appears susceptible to an experimental vaccine that seizes upon the scourge's apparatus for invading cells. Researchers prompted animals' immune systems to destroy leishmania protozoa by inducing mass production of the very protein receptor that the parasites use as a pry bar to break into blood cells. Alerting the immune system to the receptor protein protects mice and hamsters against the parasites, the scientists report in the September 11 Science Translational Medicine. Leishmania parasites are spread by the bite of sandflies. They cause skin infections and sometimes deadly swelling of internal organs. There is no vaccine to prevent leishmaniasis disease, which affects around 12 million people. What's more, the drugs used for the visceral form are costly, limited and toxic, wrote biologist Naomi Dunning-Forman in Bioscience Horizons in 2009 while at Nottingham Trent University in England. The new study, by Amitoba Mukhopadhyay of the National Institute of Immunology in New Delhi and colleagues, exploits the parasite's most obvious weakness: they cannot make heme, the iron-toting part of hemoglobin, which the parasites need to survive, and so must steal it. For that, the parasites have a receptor protein that binds to the hemoglobin in cells, setting off a process that degrades hemoglobin. This allows the parasites to extract heme. The vaccine consists of the DNA blueprint for manufacturing the parasite's receptor protein. When the scientists injected the vaccine into animals, the DNA entered cells, which then manufactured copies of the receptor protein. That flood of proteins alerted the immune system, which formed the standing army of T cells and immune proteins that identify and attack the receptor. To test whether the attack shuts down the disease, the scientists injected immunized animals with Leishmania donovani parasites, a species that causes visceral leishmaniasis. Within 60 days, more than 99% of the parasites were vanquished in the mice and hamsters. All vaccinated hamsters were still alive more than 8 months after exposure to the parasite. All unvaccinated hamsters had died by then. The researchers didn't measure survival of mice. This is definitely promising research, says Dunning-Forman, who is completing research she did for the University of Queensland in Brisbane, Australia. She notes that the receptor protein the vaccine targets shows up across all species of leishmania. It's quite incredible. Comment. Citations. R. Guher et al. Vaccination with leishmania hemoglobin receptor encoding DNA protects against visceral leishmaniasis. Volume September 5, 11, 2013. doi, 10.1126/cytranselement.3006406. Go to